Space is home to planets so strange, they sound impossible. From worlds made entirely of diamond to planets where it rains molten glass, the universe contains wonders that defy everything we thought we knew about planetary formation. Today, we'll explore incredible facts about the weirdest worlds in the universe. We'll journey to planets that are hotter than stars, worlds that orbit dead suns, and mysterious rogue planets drifting alone in the cosmic void. Throughout this journey, I'll test your space knowledge with 2 special pause and guess questions. So get ready to challenge yourself and discover planets that are stranger than science fiction. Let's begin our cosmic journey to the most extreme worlds ever discovered. The planet 55 Cancri E, located 40 light-years away, is literally made of diamond. This super-Earth contains so much carbon under extreme pressure that its entire surface could be covered in diamonds worth more than $26 nonillion. This diamond planet is twice the size of Earth, but 8 times more massive, creating crushing gravity that would instantly flatten any human visitor. The temperatures reach over 3,900 degrees Fahrenheit, hot enough to melt copper. Scientists believe there could be millions of diamond planets scattered throughout our galaxy. These worlds form when dying stars explode and compress carbon-rich materials under pressures millions of times greater than Earth's atmosphere. On these diamond worlds, mountains would be made of pure crystal, and the ground would literally sparkle under alien suns. The entire landscape would be more valuable than all the wealth on Earth combined. Another diamond-rich world is 55 Cancri E's companion planet, where diamond rain might fall from carbon-rich clouds, creating rivers of liquid diamond flowing across crystalline valleys. Carbon planets contain more carbon than oxygen, making them fundamentally different from Earth. Instead of silicate rocks, these worlds are built from graphite, diamonds, and carbides. The planet WASP-12b is slowly being converted into a carbon planet as its star strips away its atmosphere, leaving behind pure carbon materials. This process takes millions of years, gradually transforming the entire world. On carbon planets, the soil would be made of graphite and diamond dust. Rivers might flow with liquid hydrocarbons instead of water, creating an alien landscape that smells like gasoline. These worlds likely have black skies filled with carbon particles, and any mountains would be made of compressed carbon, essentially giant diamond peaks reaching into toxic atmospheres. Ice worlds beyond imagination. The planet Gliese 436b defies physics as we know it. It's a burning ice world where water exists as hot ice due to extreme gravity compressing it, despite surface temperatures of 800 degrees Fahrenheit. Europa, Jupiter's mysterious moon, contains twice as much water as all of Earth's oceans combined, locked beneath a frozen surface that hides a liquid ocean deeper than Mount Everest is tall. Enceladus shoots massive geysers of water ice 500 miles into space from its south pole. These ice fountains are so powerful, they create Saturn's entire E-ring from frozen water particles. The dwarf planet Ceres contains so much frozen water that if melted, it would create an ocean 60 miles deep, covering the entire surface, deeper than Earth's deepest ocean trenches. On the planet HD 189733b, it rains molten glass sideways at 4,500 miles per hour. These glass storms are driven by winds 7 times faster than the speed of sound, creating the most dangerous weather in the known universe. The glass rain consists of silicate particles that form when aluminum and silicon condense in the upper atmosphere. These deadly glass shards fall like microscopic bullets through the alien sky. HD 189733b appears beautiful deep blue from space, but this stunning color comes from light scattering off tiny glass particles in its atmosphere, the same particles that create the lethal glass precipitation. The glass storms on this world are so intense that they could strip the paint off a spacecraft in seconds and turn any visitor into cosmic dust before they could even scream. The planet Kelt 9b reaches surface temperatures of 7,800 degrees Fahrenheit, making it hotter than most red dwarf stars and hot enough to instantly vaporize any known metal. On Kelt 9b, the extreme heat breaks apart hydrogen molecules into individual atoms, creating an atmosphere of pure atomic hydrogen that glows like a stellar corona. Venus, our neighboring hell world, maintains surface temperatures of 900 degrees Fahrenheit due to its runaway greenhouse effect. Lead would melt into puddles on its surface, and the atmospheric pressure would crush a human instantly. The planet Coro T7b has one side permanently facing its star, reaching temperatures of 4,000 degrees Fahrenheit. This tidally locked world experiences eternal hellish daylight on one hemisphere. Kepler 10b has an entire ocean made of molten lava covering its surface. Imagine waves of liquid rock rolling across the planet like a hellish sea, with lava tsunamis hundreds of feet high. Io, Jupiter's volcanic moon, is the most geologically active world in our solar system. It has over 400 active volcanoes that continuously spew sulfur compounds 250 miles into space, painting the moon's surface in brilliant yellows and oranges. The planet K2-141b experiences rock weather. The extreme heat vaporizes stone on the day side, which then condenses and literally rains rocks on the cooler night side. On these lava worlds, the soil is molten rock, the weather involves flying molten boulders, and the oceans are seas of liquid stone hot enough to melt anything that touches them. Most exoplanets are tidally locked to their stars, meaning one side experiences eternal daylight, while the other endures permanent night. This creates temperature differences exceeding 2,000 degrees Fahrenheit. The boundary between day and night on these worlds creates permanent supersonic winds as superheated air rushes from the day side to the frozen night side at thousands of miles per hour. WASP 76b is so extreme that iron vaporizes on its day side and condenses into metallic rain on its night side. Imagine iron droplets falling from alien clouds like a deadly metallic thunderstorm. Which planet in our solar system rains diamonds deep in its atmosphere? Pause the video and make your guess. The answer is both Neptune and Uranus. These ice giants have atmospheric pressures so intense that carbon gets compressed into diamond rain. Diamonds potentially fall like cosmic hailstones through their thick, mysterious atmospheres. HD 1069L06b is a gas giant so massive it's 11 times heavier than Jupiter, yet it orbits its star at a distance 650 times greater than Earth orbits the Sun. This monster planet takes 15,000 Earth years to complete one orbit. Hot Jupiters are gas giants that migrate inward toward their stars, creating worlds with surface temperatures exceeding 3,000 degrees Fahrenheit, while maintaining Jupiter-like compositions of hydrogen and helium. The planet HATP1 is less dense than Styrofoam, despite being larger than Jupiter. This puffy planet is so light it would literally float if you could find an ocean large enough to hold it. TRIES 4b is one of the largest known planets, with a radius nearly twice that of Jupiter, yet it's so low in density that its gravity is weaker than Earth's despite its enormous size. Rogue planets in the void. Rogue planets drift through interstellar space without orbiting any star. These cosmic wanderers were either ejected from their original solar systems or formed independently in the darkness between stars. Scientists estimate there may be billions of rogue planets in our galaxy alone. Invisible worlds drifting through the cosmic void in eternal darkness and cold approaching absolute zero. PSO J318-522 is a rogue planet just 12 million years old, roughly 6 times more massive than Jupiter, floating alone in space, 80 light-years from Earth with no star to call home. These homeless worlds experience no seasons, no day-night cycles, and temperatures hundreds of degrees below freezing. They represent some of the loneliest objects in the universe. Bizarre gas giant features. Jupiter's Great Red Spot is a storm larger than Earth that has been raging for over 400 years. Wind speeds in this cosmic hurricane reach 400 miles per hour, and it shows no signs of stopping. Saturn's hexagonal storm at its North Pole is a perfectly six-sided weather pattern, 20,000 miles across, larger than 2 Earths. This geometric storm has maintained its shape for decades, defying explanation. The gas giant HD 806L06b has the most extreme elliptical orbit known, swinging from freezing cold to over 2,000 degrees Fahrenheit in just 111 hours as it approaches and retreats from its star. Neptune has the fastest winds in the solar system, reaching speeds of 1,200 miles per hour, despite being the planet farthest from the Sun's energy source. Elliptical Orbit Extremes HD 2782b has the most eccentric orbit of any known planet, swinging from 0.06 to 2.5 astronomical units from its star. During its closest approach, the planet heats up by over 1,000 degrees in just a few hours. The planet HD 80606b experiences temperature swings from -300 degrees Fahrenheit to over 2,000 degrees during its 111-day orbit, making it one of the most thermally extreme worlds known. Sedna, a dwarf planet in our outer solar system, takes 11,400 years to orbit the Sun once. Its orbit is so elongated that it spends most of its time in the frigid outer reaches beyond Pluto. Pulsar planets. Worlds of the dead. PSR B11257+ in TWO hosts the first confirmed exoplanets ever discovered, but these worlds orbit a pulsar, the collapsed core of a dead star that emits deadly radiation beams. Pulsar planets experience radiation levels millions of times more intense than anything on Earth. The surface of these worlds is constantly bombarded by high-energy particles that would sterilize any form of life instantly. The planets orbiting PSR B1257+12 were likely formed from the debris of the original star's explosion, making them second-generation worlds born from stellar death and destruction. These pulsar worlds are tidally locked, not to a life-giving star, but to a spinning neutron star that acts like a cosmic lighthouse, sweeping deadly radiation beams across space 30 times per second. Bizarre rotational properties. Venus rotates backwards compared to most planets in our solar system, and one Venus day lasts longer than one Venus year. A day on Venus takes 243 Earth days, while its year is only 225 Earth days. The planet 2M11207b rotates so fast that its day lasts only 10 hours despite being 5 times more massive than Jupiter. This rapid rotation causes the planet to bulge significantly at its equator. Uranus rotates on its side, tilted at 98 degrees, meaning it essentially rolls around the Sun like a ball rather than spinning like a top. This causes each pole to experience 42 years of continuous sunlight, followed by 42 years of darkness. Multiple star systems Kepler-16b, nicknamed Tatooine after the Star Wars planet, orbits 2 stars simultaneously. Residents of this world would see 2 suns rising and setting in alien skies, just like Luke Skywalker's home planet. The planet Kepler-47c orbits 2 stars in a habitable zone, making it potentially capable of supporting liquid water despite the complex gravitational dance of its binary star system. HD 188753AB is a gas giant that orbits 1 star, while 2 other stars orbit nearby, creating a complex 3-star system where the planet experiences constantly changing stellar radiation patterns. Pause and guess number 2. What's the shortest orbital period ever discovered for an exoplanet? In other words, what's the fastest year in the universe? Pause and guess. The answer is TOI 2109b, which completes 1 orbit around its star in just 16 hours. This ultra-hot Jupiter is so close to its star that it's being slowly vaporized, creating a comet-like tail of escaping atmospheric material. Earth-like candidates. Kepler-452b, dubbed Earth's cousin, orbits within the habitable zone of a Sun-like star 1,400 light-years away. This planet receives only 10% more energy from its star than Earth receives from the Sun. Proxima Centauri b is the closest potentially habitable exoplanet to Earth at just 4.2 light-years away. This rocky world orbits within the habitable zone of our nearest stellar neighbor, Proxima Centauri. TRAPPIST-1 system contains 7 Earth-sized planets, with 3 located in the habitable zone where liquid water could exist. This system represents the largest collection of potentially habitable worlds ever found around a single star. Kepler-442b receives stellar radiation similar to Earth and has a year lasting 112 days. Scientists estimate this planet has a 97% probability of being located in the habitable zone of its star, super-Earths. Kepler-22b is a super-Earth located 600 light-years away in the constellation Cygnus, This planet is 2.4 times larger than Earth and orbits its star every 290 days within the habitable zone. K2-18b is a super-Earth where scientists have detected water vapor in its atmosphere, making it one of the most promising candidates for potential habitability outside our solar system. TOI-715b is a recently discovered super-Earth that's 1.5 times larger than our planet and orbits within the conservative habitable zone of its red dwarf star every 19 days. Water worlds. GJ-1214b might be entirely covered by a global ocean hundreds of miles deep, making it a true water world with no visible land masses anywhere on its surface. The planet K2-18b likely has a hydrogen-rich atmosphere above a liquid water ocean, creating conditions unlike anything found in our solar system, but potentially suitable for exotic forms of life. Kepler-438b is another water world candidate, where liquid oceans might cover the entire planetary surface under a thick atmosphere that could maintain stable temperatures. Mini-Neptunes. Kepler-11 system contains 6 planets packed closer together than Mercury orbits our Sun, with several mini-Neptunes that have thick atmospheres but rocky cores. K23d is a mini-Neptune receiving similar amounts of stellar radiation as Earth, but its thick hydrogen atmosphere likely creates extreme greenhouse conditions unsuitable for Earth-like life. These mini-Neptunes represent the most common type of planet in the galaxy, yet our solar system contains no examples of these mysterious worlds between Earth and Neptune in size. Exotic habitable scenarios. Titan, Saturn's largest moon, has a thick atmosphere and liquid methane lakes, representing a completely different type of potentially habitable world, based on hydrocarbon chemistry instead of water. Europa's subsurface ocean contains more water than all Earth's oceans combined and remains liquid due to tidal heating from Jupiter's massive gravitational pull, creating a potential habitat for life beneath miles of ice. Some rogue planets might maintain subsurface liquid water through radioactive decay and geothermal heating, creating hidden biospheres in worlds drifting through interstellar space. Size extremes. Kepler-37b is the smallest known exoplanet, slightly smaller than Earth's moon. This tiny world orbits so close to its star that surface temperatures exceed 800 degrees Fahrenheit, hot enough to melt zinc. Rox-42b holds the record as one of the most massive planets ever discovered, weighing in at about 9 times the mass of Jupiter. This giant world orbits its star at a distance of 157 billion miles, nearly 40 times farther than Pluto orbits our Sun. TRES-4b is the largest known planet by radius, measuring 1.7 times larger than Jupiter, despite having a lower density than Cork. This inflated giant defies current planetary formation theories. WD-1856 Plough-534b is a planet that somehow survived its star becoming a white dwarf. This world is now 7 times larger than its dead stellar companion and orbits the white dwarf every 34 hours. Speed records. PSR J1719-1438b orbits its pulsar companion every 2.4 hours, making it one of the fastest orbiting planets known. This diamond planet races around its dead star at speeds exceeding 300,000 miles per hour. WASP-103b is being stretched into an egg shape by its star's gravity due to its incredibly close 22-hour orbit. The planet bulges toward its star like a cosmic teardrop frozen in orbital motion. 55 Cancri completes one orbit in just 18 hours, meaning a year on this diamond world lasts less than 1 Earth day. The planet is tidally locked, with one side permanently facing its star. Temperature extremes, Kelt 9b, holds the record as the hottest known planet at 7,800 degrees Fahrenheit, hotter than many stars. The dayside temperature is so extreme that molecules cannot exist, only individual atoms. OGL 2016 BLG 1195LB is one of the coldest known planets, with surface temperatures around -400 degrees Fahrenheit. This frozen world orbits its star at nearly the same distance as Earth orbits the Sun. The rogue planet CFB-DSIR 21490403 drifts through interstellar space with surface temperatures of -234 degrees Fahrenheit, making it one of the coldest known objects that isn't a star. Density extremes. IWASP-17b has a density lower than Styrofoam, making it the least dense planet known. Despite being twice the size of Jupiter, this puffy planet would float on water if you could find an ocean large enough. PSR J1719 1438b is likely the densest planet known, composed entirely of crystallized carbon. Essentially a planet-sized diamond, with density approaching that of a white dwarf star. Age records. The planets in the Kepler 444 system are over 11 billion years old, making them more than twice as old as Earth and nearly as old as the universe itself. These ancient worlds formed when the Milky Way was young. V830 Tauri b is one of the youngest known planets at just 2 million years old. This infant world is still glowing from the heat of its formation and shrinking as it cools. Magnetic field extremes. Jupiter's magnetic field is 20,000 times stronger than Earth's, extending millions of miles into space and trapping deadly radiation in powerful Van Allen belts that would kill any spacecraft not properly shielded. HAT P11b has a magnetic field so strong it strips material from its own atmosphere, creating a comet-like tail of escaping gases that extends millions of miles behind the planet. Planets we might colonize. Mars remains humanity's most likely first interplanetary colony. Recent discoveries of subsurface water ice and seasonal methane emissions suggest Mars might still harbor microbial life in underground reservoirs. Titan, Saturn's largest moon, offers Earth-like atmospheric pressure, abundant organic materials, and liquid hydrocarbon lakes that could provide fuel for future space missions. The main challenge is the -290 Fahrenheit surface temperature. Europa's subsurface ocean contains more than twice the water of all Earth's oceans. Future robotic missions might drill through the ice shell to explore this alien sea and search for life in its dark depths. Proxima Centauri b, being our closest potentially habitable neighbor, represents humanity's best target for interstellar exploration. Advanced spacecraft might reach this world within 20 to 40 years using breakthrough propulsion technologies. Hidden planets in our solar system. Planet 9, if it exists, might be a super-Earth orbiting 20 times farther from the Sun than Neptune. This hypothetical world could explain the strange orbital patterns of distant Kuiper Belt objects. The outer solar system likely contains dozens of dwarf planets we haven't discovered yet. These frozen worlds lurk in the darkness beyond Pluto, waiting to be found by future space telescopes. Some scientists propose that our solar system might contain captured rogue planets, worlds that originally formed around other stars, but were gravitationally captured by our Sun during close stellar encounters. Detection method. Mysteries. Gravitational microlensing has revealed planets we can never study in detail because the lensing effect only works once. These one-shot discoveries hint at planets we'll never see again. Some exoplanets are detected only by the gravitational wobble they create in their parent stars. We know these worlds exist, but we'll never know what they look like, what they're made of, or whether they have atmospheres. Transit photometry can only detect planets whose orbits happen to cross between their star and Earth. This means we're missing 99% of all exoplanets because of our limited viewing angle. Future space telescopes. The James Webb Space Telescope has already revolutionized exoplanet science by analyzing atmospheric compositions of distant worlds. Future observations might detect biosignature gases that could indicate alien life. The Roman Space Telescope will use gravitational microlensing to discover thousands of new exoplanets, including free-floating rogue planets drifting between the stars. Proposed future missions like LUVOIR could directly image Earth-like exoplanets and analyze their atmospheres for signs of life, potentially answering the ultimate question of whether we're alone in the universe. Life in extreme environments. Recent discoveries of extremophile organisms on Earth living in conditions previously thought impossible suggest life might exist in environments we never considered habitable. Subsurface oceans on icy moons like Europa, Enceladus, and Titan might harbor ecosystems based on chemosynthesis rather than photosynthesis, creating alien biospheres in eternal darkness. Some scientists speculate that life might exist in the upper atmospheres of Venus, floating in cloud layers where temperatures and pressures are more moderate than the hellish surface. The discovery of phosphine gas in Venus's atmosphere sparked debates about possible aerial microbial life, though the findings remain controversial and require further investigation. Breakthrough technologies. Breakthrough. Starshot aims to send tiny spacecraft to Proxima Centauri at 20% the speed of light using powerful laser arrays, potentially reaching our nearest stellar neighbor within 20 years. Advanced telescope arrays might eventually resolve surface features on nearby exoplanets, allowing us to map alien continents, oceans, and weather patterns from dozens of light-years away. Future space missions might use solar sails or fusion ramjets to reach nearby star systems within human lifetimes, making interstellar exploration a reality rather than science fiction. Toxic and bizarre atmospheres. Venus has an atmosphere so dense it creates surface pressures 90 times greater than Earth, as equivalent to being crushed under 3,000 feet of ocean water. The atmosphere is 96% carbon dioxide with clouds of concentrated sulfuric acid. The planet GJ 436b has a comet-like tail of hydrogen stretching millions of miles behind it as its atmosphere is slowly stripped away by stellar radiation. This Neptune-sized world is essentially evaporating in space. Titan has a thick nitrogen atmosphere with methane clouds that create weather cycles similar to Earth's water cycle. Instead of rain, Titan experiences methane precipitation that fills vast hydrocarbon lakes. Extreme weather systems. Jupiter's Great Red Spot contains winds reaching 400 miles per hour and has been continuously raging for over 350 years. This storm is so large that 3 Earths could fit inside it with room to spare. Neptune experiences the most violent weather in the solar system, with wind speeds reaching 1,200 miles per hour, faster than the speed of sound on Earth. These supersonic winds occur despite the planet receiving almost no solar energy. Extraordinary moons. Io experiences tidal forces from Jupiter so intense that the entire moon flexes like a rubber ball, generating enough internal heat to power over 400 active volcanoes that continuously reshape the surface. Enceladus has geysers erupting from its south pole that shoot water ice 500 miles into space. These fountains contain organic compounds and salts, suggesting a warm subsurface ocean that might harbor life. Miranda, one of Uranus's moons, looks like it was shattered and reassembled. This bizarre world has cliffs 12 miles high and a patchwork surface that suggests catastrophic impacts in its past. Spectacular ring systems. Saturn's rings contain billions of ice particles ranging in size from tiny grains to house-sized chunks. These rings are incredibly thin, only about 30 feet thick despite spanning 175,000 miles across. The exoplanet J14407b has a ring system so massive it would extend from the Sun to beyond Mars if placed in our solar system. This alien ring system is 200 times larger than Saturn's rings. Biosignature detection scientists search for atmospheric combinations that can only exist with living processes, such as oxygen and methane together, which would quickly react and disappear without biological replenishment. The James Webb Space Telescope has begun analyzing exoplanet atmospheres for water vapor, carbon dioxide, and other molecules that might indicate habitability or even active biological processes. K2-18b shows signs of water vapor and possibly hydrogen sulfide in its atmosphere, making it one of the most promising targets for detailed biosignature analysis in the coming years. Habitable zone evolution. The habitable zone around stars changes as the stars age and evolve. Planets that start outside the habitable zone might move into it as their star brightens over billions of years. Mars was likely habitable billions of years ago when the Sun was dimmer and Mars received optimal heating. Evidence suggests ancient rivers, lakes, and possibly oceans covered the red planet's surface. Exotic life possibilities. Titan's hydrocarbon lakes might support entirely different forms of life based on methane chemistry instead of water, creating alien ecosystems unlike anything on Earth. Subsurface oceans on icy moons like Europa might harbor ecosystems based on chemosynthesis, deriving energy from chemical reactions rather than sunlight, similar to deep-sea hydrothermal vent communities on Earth. We've journeyed through a universe filled with worlds that challenge everything we thought we knew about planets. From diamond worlds worth more than Earth's entire economy to hellish planets where glass rains sideways at thousands of miles per hour, the cosmos contains wonders that dwarf our imagination. We've discovered planets hotter than stars, worlds that rain molten metal, and mysterious rogue planets drifting alone through the cosmic void. We've explored ice worlds with subsurface oceans, gas giants less dense than styrofoam, and ancient planets older than our solar system. The universe contains an estimated 100 billion galaxies, each potentially hosting billions of planets. The worlds we've discussed today represent just a tiny fraction of the cosmic menagerie waiting to be discovered. Future space telescopes and interstellar missions will undoubtedly reveal even stranger worlds, planets that will make today's most extreme discoveries seem ordinary by comparison. What fascinates you most about these alien worlds? Drop a comment below, sharing which planet blew your mind the most. Did you guess correctly on our 2 quiz questions? Let me know your score. If you enjoyed this cosmic journey, smash that like button and subscribe for more mind-bending space content. Hit the notification bell so you never miss our latest discoveries about the universe's most incredible secrets. Next time, we'll dive into black holes, the cosmic monsters that bend space and time itself. Until then, keep looking up at the stars and wondering what incredible worlds might be orbiting them. Thanks for joining me on this amazing journey through the universe's most extreme planets. The cosmos is vast, mysterious, and more incredible than we ever dared imagine.